right, Algebra 2, here are the solutions to your Chapter 9 review. So first one, it wants you to draw the angle in standard position. So that means your initial side's on the positive axis, 310 degrees. Well, 270 is here, so 310 would bring me around about, obviously you're just approximating, I'm going to say around here. That would be 310 degrees. That means your reference angle is the distance to the nearest x-axis. And if this is 310 and this is 360, my reference angle is going to be 50 degrees. And now to get the two coterminal, so that was the reference angle. The two coterminal angles, one positive, one negative, since this is degrees, you're going to just add and subtract 360. So that would give me 670 if I add 360 and negative 50 degrees if I subtract 360. And then to convert, remember we'll do that in a different color too. You take your 310 and you multiply it by pi over 180. And then we can simplify. Really all we're going to do here is cross out the zeros. So this will become 31 pi divided by 18. And that would be 310 degrees in radian mode. All right, now we come over and do in radians, we have 5 pi over 6. So again, your initial side will be at 0 degrees. 5 pi over 6 is equivalent to 150, kind of giving away the conversion. Sometimes doing the conversion might be easier. Let's show how I got that. 5 pi over 6 gets multiplied by 180 over pi, so that the pi's cancel, and 6 goes into 180 30 times. 5 times 30 gives us 150 degrees. But we are graphing this in radian mode, so here is approximately your 5 pi over 6. And that means the reference angle is this distance to the nearest x-axis, which with radians is really easy. You just pick off this part, so it's pi over 6 or 30 degrees. Now for the coterminal, you're going to be adding and subtracting 2 pi since this is in radian mode, but we need a common denominator. So we're going to be we're going to add and subtract 12 pi over, sorry, I just had a moment, 12 pi over 6, because that's equivalent to 2 pi. So if I add, that will give me 17 pi over 6, and if I subtract, I'm going to have negative 7 pi over 6. All right, so that would be those first two. Now you're going to use your unit circle, and hopefully you have one handy. I have my little cutout of one. So sine of negative 90 means you're going down to 270 degrees. The y value there is going to be a negative 1. Then you can find 225 is in the third quadrant. Cosine is the x value, so that will be a negative rad 2 over 2. Tangent of 3 pi over 4, that's in the second quadrant. Tangent is the ratio of y over x. So when you take that ratio, you get a negative 1. And then sine of 240, the y value at 240 is a negative rad 3 over 2. Now we get into our reciprocal functions. Cosecant of negative 210, that's the same thing as 150. The y value here, so we're going to take the reciprocal of the y value. The y value is 1/2, so the reciprocal is going to equal a positive 2. Secant of 135 is in the second quadrant, and it is the reciprocal of your cosine. Now realize rad 2 over 2 is already if I were to draw a little triangle here, so you have a 1, and a rad 2. So we're doing the ratio of the hypotenuse over the adjacent, and in the second quadrant it will be negative because this will be a negative. So it's going to be a negative rad 2. Cotangent of 300. So cotangent is the x over the y. And so you're just looking at the numerators. It would be 1 over negative rad 3, which rationalizes to negative rad 3 over 3. And then tangent of pi over 2, again that's y over x, 1 divided by 0 is undefined. That's where you would have an asymptote on your graph. All right, so you can use your unit circle to figure those out and use your ratios to simplify. Now we are going to do a couple graphing. So first one is a cosine. The sinusoidal axis, that's this first number. That's going to be a negative 2. My amplitude is going to be 2. My period is going to be 2 pi divided by that pi over 2. And that simplifies out to 4. And my phase shift tells me that I'm going to start at 1, which tells me I'm going to end. You always add the period and the phase shift, so I'll be ending at 5. That allows me to set up my axes now. So my x-axis, I'm going to start at 1. I'm going to end at 5, because that's 4 plus 1. That's a distance of 4. Halfway is 3. Halfway here is 2. So this is a nice one to sort of label the x-axis. Now the y-axis, I'm starting down here at a negative 2 and an amplitude of 2. That's going to bring me up to 0 and down to a negative 4. And since it's cosine, cosine always starts high, then hits the sinusoidal, then hits a low, then the sinusoidal, then a high. And so to make it look like it's going to keep going, we kind of just do our turnarounds, and there's your graph. Now let's look over here at our sine graph. Sinusoidal axis here is 3, and the amplitude, there's a 1 right here. If you don't see anything, it's a 1. Notice you have a 1 right here for the period, so that means it's just going to be 2 pi. Divided by 1 is 2 pi. And where are we starting? Since it says plus 90, we're going to start, oh, sorry about that. I shouldn't have said 2 pi. This was in degrees, so this one we get to label as 360, which is equivalent to 2 pi. And we're starting at a negative 90, which means I'm going to end at 270 when you add the period and the phase shift. So I'm going to start back here at negative 90. Here's 0, here's 90, 180, 270. So there's my 1, 2, 3, 4, 5 spots. My sinusoidal is going to be up here at 3. Add 1 to go to 4, subtract 1 to go to 2. And this is a sine graph, which starts on the sinusoidal. So at negative 90 and 3 we start, then we go high, then sinusoidal, then we go low, and then we complete our cycle on the sinusoidal. So sine is always about the sinusoidal. Here we go. All right, now we are down to our tangent graph. So remember, your parent graph would go from negative pi over 2 to pi over 2. That would be the original parent graph. But this one has a horizontal shrink by a half. Remember, horizontal always works the opposite. So if I multiply each one of these by the reciprocal of 2, that means I'm going from negative pi over 4 to pi over 4. It still is negative in this pre-first quadrant, positive in the first quadrant. And so that would be your graph. We don't actually need these. And that is a distance, 45 and 45 is a distance of 90 degrees. But since we are in radians, my period is pi over 2. Now your secant graph, remember, comes off of your cosine graph. And so this one is going to have an amplitude of 3. There's no different vertical shift. Actually, I'm going to put that down a little bit because it comes off of that, so we don't want it too high. So here's 3, here's -3. That's going to be my amplitude. The x-axis is still our sinusoidal. But this 2 means that my new period is 2 pi divided by 2, which is a distance of pi. If you would rather do it as 180, I really don't care. They're both the same concept. So if you wanted to do that, now cosine, usually we start at 0, and now we're going to finish one cycle at pi, which means I'm going to put a negative pi back here just for the sake. This halfway would be pi over 2. I am going to spread this out because it's going to be kind of tight. I'm going to put my pi way out here. So halfway would be pi over 2. This would be pi over 4, 3 pi over 4, and I'm going to put a little negative pi over 4 here. Now, if this were a cosine graph, I'm going to do it in a very light yellow. It would start high, and it would do this. That would be the cosine, and then we would connect the dots. But what we care about is a secant graph. So remember, wherever it hits the sinusoidal, that is going to be an asymptote. And actually, I would have, if I'd gone backwards, that would be. So I'm going to do this. And then off of the high, we do a little parabola here. And off of the low, we do a parabola there. And that is a full cycle of pi. Now for this next problem, I'm actually going to do it 2 ways, which you don't have to, but I just want to emphasize that it could. So this first way I'm going to write is based on this pink outline. Notice that it starts on a sinusoidal. This is the middle point of that graph. So I know that my vertical shift is at 1. If I count up from there, I notice that my amplitude is 5. I can see that I finish my cycle, it takes 2 units, which means the b value will be 2 pi divided by 2, which is just pi. And then for the pink graph, my phase shift, where do I start? I start at 0. So putting that together, I get a graph y equals 1 plus 5. It's sine because it started on the sinusoidal. And then this would be pi times x. Now, if you wanted to do this as a cosine graph, you'd want to start high and end high. So everything would be the same except for where you start. It really is the same thing. So if I was going to do it as a cosine, it would look like y equals 1 plus 5. That's all the same, cosine, same period. But now my phase shift is at 1/2, since this is about 1/2 right there. They are equivalent, and it doesn't matter which way you give. Sine might have been easier because your phase shift was 0, but they're both totally acceptable. Now we have the Ferris wheel problem, which you have done several times already. So let's look at what this is. 60 feet in diameter. So I have a Ferris wheel here. So 60 feet in diameter, which means the amplitude will be 30. It completes 1 revolution every 3 minutes. That means the period is 3 minutes, which tells me my b value will be 2 pi divided by 3. Assume the closest a chair gets to the ground is 5 feet. Makes sense because you don't want to hit the ground. So that's going to let me start to label my y-axis, which is actually h of t, the height with respect to time. So the low point here is 5. If you add that to your 60, I'm up here at 65. I have an amplitude of 30, so this middle sinusoidal is going to be at 35. All right, now what else did it tell us? and that a writer first reaches this minimum height at t equals 2. So I'm starting, that's your phase shift, at t equals 2. So here I'm going to start, and we know it takes 3 minutes to finish, so I will finish at 5. So this is t in terms of minutes. So we're starting at t equals 2, we're at a low point, and at 5 we complete the cycle, so we're at a low. Half of that is going to be 3.5. That's when I'm going to hit the high value. And then averaging 2 plus 3.5, divide by 2. You'll do that on your calculator. So that puts me at the sinusoidal here. And 3.5 plus 5 divided by 2 is 4.25. And so the graph is an upside down cosine graph. So that upside down, low to low, is a reflection. That means right before my amplitude, I am going to put in a negative. So the equation will read my sinusoidal minus the amplitude of 30, because that represents the reflection, so that it's low to low. This is a cosine graph. The b value is 2 pi over 3. Oh, somehow my colors changed. I think that's okay. And we're starting at 2, so this will be t minus 2. And that should just be 2 pi over 3. And that would be the equation. Okay. All right, now on to using some of our identities. So this one says, find the exact value of cosine 165 using a sum or difference. So I know that cosine 165, and again, there's many different ways to do this. I'm going to choose 120 degrees plus 45 degrees, because that adds up to 165. So then you might want to get out your notes for cosine a plus b. This is a, this is b. This will be cosine 120 times the cosine of 45 minus sine of 120 times the sine of 45. And then you'll look at your unit circle. Cosine of 120 is a negative 1/2. Cosine of 45, rad 2 over 2. Sine of 120 is a positive rad 3 over 2. And sine of 45, rad 2 over 2. So when you put it all together, we have a negative rad 2 minus rad 6 over the common denominator of 4. And that would be your final solution. Notice we didn't use a calculator on these. Okay, find the exact value of cosine 2 theta given these clues. So the clue tells me I'm going to draw my triangle in the second quadrant. It's going to be one of your bow ties. And its sine is 5 opposite over hypotenuse, so that's the opposite. That's your hypotenuse. By Pythagorean theorem, the adjacent is going to be negative 12. Pythagorean will only tell you that's 12, but you need to know in the second quadrant the x value would be negative. Now, with cosine 2 theta, if you look at your sheet, you have 3 different options. I'm going to choose the option that has it in terms of sine, because they told us what sine is. So I almost don't even need the triangle. So this is 1 minus 2 5/13 squared. So 1 minus 2 times 25 over 169. So I have a common denominator of 169. So I'm going to go 169 over 169 minus 50 over 169. And that gives me 119 over 169 is my final answer. Okay, so you're setting up your triangle. You could, depending if it's a cosine 2 theta, you have options, and you're going to read off what the ratios are. Just be careful when you're setting up your triangle. Pythagorean won't give you the positive or negative for a side in a different quadrant. All right, now we have solving. So 4 sine theta plus 2 equals 0, and we want all the solutions within 1 revolution of our unit circle. So first thing I want to do is isolate my sine theta. So I'm going to subtract 2, then I'm going to divide by 4 so that I have sine theta equals a negative 1/2. And remember, sine represents the y value, so you're going to see your answers down below the x-axis. And it turns out the y value is a negative 1/2 at 210 degrees and 330 degrees. They both have the same reference angle of 30 degrees. And then our last solving problem over here, solve. Now, notice this is sine 2 theta plus 2 cosine. We have to have all the same argument. So I'm going to use my identity to rewrite sine 2 theta as 2 sine theta cosine theta plus 2 cosine theta. So first we use the identity. Now we find the GCF. Both terms have a 2 cosine theta in common. So I'm going to pull it out, and I'm left with sine theta plus 1. And I can now set each one of these equal to 0. So 2 cosine theta equals 0 is the same thing as cosine theta equals 0, because you can divide by 2. And looking at your unit circle, where do you see the x value is 0? You're going to see it at 90 degrees and at 270. And over here I have to solve sine theta plus 1 equals 0, which means sine theta equals a negative 1. Looking at your unit circle, where do you see a y value? That is negative 1. That only happens at 270. So putting those two together, we don't have to write the repeats twice. It's still the same angle measure. So that would be my solution. Okay, final page. And just like it'll be just like this on the test, you'll only really have 1 or 2 problems at most that require a calculator. So this will definitely be a calculator problem. So we want to solve the given triangle. We were given side, side, side. So if this is A, B, and C, little a was 9, little b is 15, little c is 20. I kind of gave you a hint here that you always want to solve for the biggest angle first so you don't run into problems. That would be angle C because it's opposite the longest side. So we use our side angle side here and then the opposite side. So this will be 20 squared equals 5 squared plus 9 squared minus 2 times 15 times 9 times cosine of angle C. And so our goal is to solve for cosine C to start with, so we're going to isolate it. So 20 squared minus 15 squared minus 9 squared, so that'll bring these over, divided by this coefficient, negative 2 times 15 times 9, that equals your cosine of C. So when you work this out, it's going to give you 94 over negative 270. And how do we find C? We take the inverse cosine of that value. And when you do that, you get 110 degrees. So that is angle C. We know this is 110. So you only need to do law of cosines once given side, 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 because now I have a pairing of a side and an opposite angle. So I'm going to solve for angle B using law of sines. So I know that the sine of 110 is to the opposite side, as the sine of angle B, which I don't know, is to its opposite side. I can multiply both sides by 15, and when I work this out on my calculator, it will tell me that the sine of B is going to equal 0.705. So we do the inverse sine to find out what actually angle B is, and we round off to about 45 degrees. And angle A is found by just subtracting from 180. So 180 minus 110 is 70. 70 minus 45 leaves me with 25 degrees for angle A. All right. And this last problem is a right triangle problem. So there's several ways to do this, but what I'm going to do, that 28 goes with this angle in that little corner here. I'm going to label this side right here Y, and I'm going to label this whole base here Z. We're trying to figure out what is X, which is not a full base of a right triangle. But if I were to find Z and I subtracted Y, it would leave me with X. So that's my strategy. I'm going to do two right triangle problems and find Z and Y. So to find Y, I notice this is the opposite, this is the adjacent. That's a tangent. So the tangent of 52 degrees is the opposite, which is 65, over the adjacent, which we're calling Y. When your unknown's in the denominator, remember that means it goes up and the tangent goes down. These two switch positions. And this you can then just enter on your calculator. 65 divided by tan 52, that's going to give me Y as 50.78. All right, now let's find Z. So with Z, it's also opposite and adjacent. So we know that the tan of 28 is 65 over Z. So they switch positions. Z is 65 divided by tan 28. And so Z, going to our calculadora, is 122.25. So we can then just find X by taking 122.25 and subtracting 50.78, and that's how we get X is 71.47. All right, there we go.